Hello, this is the first in a series of videos about how to make maps in D3 version 4. So this map here, this first one, is going to be a map of the world and it's going to have a few capitals on it. So it's going to be a very, very simple map. And making maps in D3 is honestly pretty simple compared to a lot of the other things you can do. So if you've been following along with other videos, you'll probably be very relieved to see what's going on here. All right, so let's start off by looking at our basic JavaScript, our visualization.js. This is the standard sort of JavaScript that we use whenever we build D3 visualizations. We start off by creating a margin, height, width. We select something on the page. We put an SVG in it. We set its height and width. We put a group object inside of that. Move it around so we have a margin. Then we queue up what we're going to import, and then we start processing it. So the one thing that's changed between this visual and the other visuals that we've done is right here for our file that we're importing. It's not a CSV file. 99 times out of 100, we read in files that are CSVs. Later on, we'll read in this capitals.csv file. But if we look, we see it is a .topojson file. Generally, this would just be .json, but the file itself is something called topojson. And if we look at it, it looks real pleasant. What we need to know for this visual is topojson is basically a fancier, nicer form of a file format called GeoJSON. So if we go to geojson.io, it is a wonderful place where you can build maps in this format called GeoJSON. So if we look on the right, we see there's a type and features and all kinds of coordinates that make up this line string. Maybe if we put down some markers, we can see that as well. Now this is GeoJSON, and the problem with GeoJSON is that it is very large. If you want to have a map of, say, all of the counties in the United States, you are talking a long download time for your user. And because the point of D3 is generally to produce things for the web, you want to make sure that your file sizes are small. So topojson, if I can hop on over to GitHub, it's up to version 2 now, and it takes away pretty much all the fun functionality of version 1. So we'll refer to another video on how to use topojson, but it's a wonderful file format, and you should always be using it whenever you are pulling in map data or geographic data for D3. Well, not always. So a CSV file is really good for point data because you just have a latitude and a longitude. But for anything else, shapes, counties, states, countries, anything like that, you're going to want to use topojson. So, all right, we have this file. Let us spin up our server and visit our page. So this is the first one. This is the world. And hopefully there's no problems initially. No, everything's good. All right, so right now we have an SVG. It doesn't have anything in it. I'm going to add a little bit of a background on it just so you can see something later on. So I'm going to say SVG. Let's have your background be EF. Okay. So inside of our visualization.js, we are pulling in d3.json, or we're reading in world.topojson. We're saying please process it with the D3 JSON processor. And now we're going to go down here, and I just want you to see what the data looks like. So we're going to console log the data, refresh, and come over here. So inside of this topojson object, it's got arcs, it's got bounding blocks, it's got objects, it's got transforms. It's real exciting. The stuff that we're interested in is inside of objects. Every single time you read in a topojson file, there will be an object section, and those objects will have all of the information that you need to draw your geographic bit. So for example, right now we have countries. This is going to be a series of countries that we're going to draw on this map. You might also have states. Maybe you'd have, you could have an infinite number of different objects in here, but you're going to treat them all separately. So how do we map these countries? Well, the first thing that we need to do is convert from topojson into a format that is usable by us. If we go back to our index file, we can see that we are including topojson version 1.min.js. So we're pulling in D3, then we're pulling in topojson, and then we're including visualization.js, which is our file. So just make sure that anytime you're doing maps, you include topojson as a library. So we are going to use something called topojson.feature, which is going to extract all of the countries from our topojson and turn it into something we can use. So var countries equals topojson.feature. Topojson.feature, you have to send it two different things. First, you have to send it the root of your data, which is basically your topojson file, which for us is data. And then you have to send it the specific data that you're looking for. So in this case, this is our data, and then we have objects, and then we have countries. So we are going to be looking for data.objects.countries. Every single time you are reading in topojson, you are going to want to console log, and then look inside of objects, and then figure out what the key name is, where your data is living. So ours, as I've said 100 times, is countries. Yours might be states. Yours might be some strange code from the US Census Bureau, anything like that. And then we do .features. So every single time that you pull in topojson, you are going to write this. And just to confirm that we got some countries out of this, I'm going to save. I'm going to refresh. Hey, look at that. It's a big long array full of a bunch of different countries. And so every country has, let's see, it has an ID, it has a type, properties, and geometry. So we can see that geometry seems to have maybe latitude and longitude hiding inside. Properties has color and name. So yes, this is all of our country data. So when we are trying to draw countries, countries are shapes. And as we all know, shapes mean we are going to make path objects. So let's just pretend that this is not topojson. That is not something we've never done before. We have, 242 different countries in here, I believe? 242, yes. So let's just do an SVG, select all. Our paths, we could just do path here, but let's be a little more proper. Let's call it .country. We're going to give it a class of country. We'll bind our countries. We'll do an enter. We'll add a path for every single country. And then we will set it to be a class of country, just so this and this match up. So we can save it if we want. We can refresh. And if we wanted to look at this, we could see that we now have one path for every single country. So the thing is about paths is they need only one attribute in order to show up. They need an attribute that is D. Now, D is basically a list of coordinates and a certain way to move between all those coordinates in order to draw a shape. But how do we turn this data here, maybe these properties, maybe this geometry, how do we turn that into something that we can use to draw a shape inside of D? All right, we're going to do two things. First off, we need to make a projection. So projection, when you have a globe, it's round, as we all know, or I hope we all know. Our screen, however, is flat. So we need a way to translate between a round globe and say, okay, I know the globe is round, but we need to display it on the screen. So change those numbers, change those latitude and longitudes a very specific way to get it to end up on a flat screen. We'll have another video about that. But for now, here's what we're going to do. There are several different projections. Projections is what you use to convert from a globe to something flat. There are several different projections. We are using a pretty standard one called Mercator, and in order to use it, just d3.geomercator. We want to center it in the middle of our visual, so we are going to do width divided by 2, height divided by 2. This is going to center it. Later on, we'll scale it to zoom in or out a certain amount, but for now, let's just stick with this very basic projection. So even though we now have a projection, we need some way. That's very good for, let's say, points. So I say, here's a latitude and longitude, and the projection will say, here's an x and a y. I say, here's another latitude and longitude for another city, and it says, here's the x and y on the screen that city should be displayed at. But what we're going to do now, the second step is, a shape is built on a ton of different points. It's basically drawing a line. So in the same way that when we made line graphs, we had a line generator, we need to do the same thing for a map visual. So var path equals d3 geopath projection, projection. Every single time you have shapes on a map, you are going to do these two things. Sometimes, we'll make another map where this changes here, but maybe 100 times out of 100, you are going to have this line. Var path equals d3.geopath.projection, projection. And this is just the way that long series of dots that make up a shape will be filled in and will turn into the D of a shape. So let's do this. All right. We are going to take that path variable that we made up here, this geopath, and we are just going to feed it right to D. We're going to save. And there we go. We have very easily and very simply put together a map. There's a problem though, and the problem is that we are zoomed in a little bit too far. So what we're going to do is we're going to do two things. First, we are going to go to our projection and we're going to try to scale it. You can put in a ton of different numbers for scale, and a lot of the game you're playing with a visual is going to be inventing the right number for your scale. So I'm going to save this. Let's try it at 100. Oh, that actually doesn't seem that bad. If you started off with scale and you did scale, say scale 10, you're going to end up very, very far away. And then if you did scale, let's say 1000, you're going to end up much, much closer. So you end up using scale in order to zoom in or zoom out. So we're just going to stick to 100, and it's going to look fine. We want to change the way that these shapes look. So usually when you're doing paths, you go down here and you'll do ATTR fill, and we'll make it something kind of light, CCC, CCC. Now I have some nice gray bits. When you do maps, it's, I would say, probably more important than when you do other visuals. Instead of doing it via ATTR fill, you're going to want to write some CSS for this. So we're going to get rid of that, and we're going to think, okay, our class for these is country. So let's go into index. We'll make a new rule, and we'll make the fill for these be CCC, CCC. A white background here. All right, and maybe we'll draw some lines around each of these. So let's make our stroke be a darkish black, and we'll thin those lines out a little bit. So stroke width, maybe 0.5. Okay, that looks a lot better. That looks like a real map. Okay, so it was remarkably easy to draw this map. all it took was a projection, a geopath, this line to pull the features out of our topojson, and then we just did our normal data binding, enter append, and just added that attrd path, and then life is wonderful. Now it's great because you can you can treat these just like you would circles, just like you would rectangles, just like you would anything else. For example, we could have on click D3 select this, ATTR fill yellow. So every single time we click on one of these paths, it is going to turn the fill to yellow. That did not work. That did not work. That did not work. Why would that not have worked? Oh, it's being overridden by the CSS. So what we're going to have to do instead is classed selected true. So what this is going to do is it's going to say add the class of selected to the element that is being clicked. This says get the element, this says get the shape on the map, and then you do dot class, and it says, you know, add the class selected. So we are going to say selected, the fill is yellow. Wonderful, right? We could also do this for hovering. We could say on mouse over, add the class selected, and then on mouse out, remove the class selected. Remove the class selected, add the class selected. And so there we go. We get a nice kind of hover event as we go over these. Now, one more thing we're going to do. Adding shapes is this very easy piece here. Adding dots is a little bit more complicated. So here's what we're going to do. We are going to pull in one more file. We're going to defer, we're going to do d3.csv, and we're going to pull in capitals.csv, which is this file right here. We are going to, because it is another thing we are deferring, it is the second file here, so it will end up being the third thing here. So data is world.topojson, and now capitals is going to be capitals.csv. And if we want to make sure that we're doing this, console.log capitals, save, refresh, and hey, look at that. We have a whole bunch of capitals coming along there. So for our capitals, we would like to put dots down for each of them. So svg.selectAll, and we're going to call these maybe city circles. We're going to bind our data, enter, append. Because these are going to be circles, we're going to add circles to them. And we will make them, I don't know, not very big, just give them an R of 2. Now, when we have a circle, we need to set two things. We need to set a CX and a CY. So right now I'm making all of these circles show up on top of one another at 10, 10. So I'm going to refresh, just make sure they show up. And hey, look at that. We have some circles there that actually look like boxes, but such is life. Okay, so what we need to do is each one of these, if we look at the data itself, there is a lat column and there is a long column, and we need to convert that into something that is usable with x and y. So because the CX is going to be different for each of these, we're going to throw in a function here, and because the CY is going to be different for each of these, we are going to throw in a function there. Now, let's just look at our data point just for kicks. We'll refresh, and we see yes, we have a latitude and we have a longitude. So how are we going to convert this to an X and a Y that shows up on the page? So if we think back, we made this fun thing here, this projection. And what the role of the projection is to convert latitude and longitude, things on a globe, to something that will exist on the screen. So let's just feed our latitude and longitude to that projection and see what we get back. So let's say var coords equals projection, and then as a list, long and d dot lat, and we'll console.log that. So we're saying, hey, there's a projection. It's the way to translate from a globe to a flat world, to a flat screen, and we're going to give it the latitude and longitude. So these are the column names from here, long and lat. I didn't make those up. All right, we refresh, and now, hey, look at these numbers. These numbers are X and Y coordinates. Now, we're setting the CX right now, so we don't need both of these numbers, right? We only need one of them, we only need the X. So X is the first one, X is 0. So we are going to return coords 0. Now the weird thing is that, I mean, it's kind of weird. In order to get the X coordinate, we don't just look at the latitude, we don't just look at the longitude. We have to feed both the latitude and the longitude into the projection, get the coordinates, and then only return one of the coordinates. So we do the same thing for the CY, except instead of only returning the X, we are only going to return the Y, which is 191 in this case, and the X is 270. We're going to refresh, and look at that. We have some wonderful little cities showing up on our map. Now we're going to do the exact same thing for the text. If we were smart, we could have done G elements for each of these and added the dot, added the circle, and added the text inside of that. But we're not very smart, so we're just going to do these separately. So in the same way that we did select all city circle, data capitals, blah, 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 SVG, select all, city label, data capitals, enter, append, text. Now, the way that I like to do text labels is I like to set the X and Y to be right on top of the dot. So we're going to change this to X, and we're going to change this to Y, and then we're just going to say text, this is a capital, just to make sure that it works. Because text elements, ATTR class, city label, these need X and Y coordinates, and then they need this text bit here. So let's save, let's refresh, and there we go, we have some text there. Instead of this is a capital function D, let's just look at our data real quick to see how we get the name out of it. We scroll down and we just do D dot name. So we are going to do return D dot name, show us the name, and now first thing we're going to make this a bit smaller. Let's make it a bit smaller using CSS actually. So we're going to steal this class here, the city label class. We're going to go in here to our index. We're going to go dot city label, font size. Let's just make it 10 pixels, nice and tiny. Okay, that's nice and small. And now we need to offset it to the right and down a little bit. So the way we do that is, like I said, we could add, 10 here, we could add 5 here. But I like to stick with dx, which is the offset on the x-axis, and dy, which is the offset on the y-axis. So I'm going to save, I'm going to refresh, and now you'll see that each one of those labels was pushed 10 pixels to the right and 5 pixels down, which was clearly far too much. So maybe we want 2 pixels down and maybe 5 pixels over. So 2 pixels down, 5 pixels over. Give it a save. we're looking good. So things you can do on this map, you can't see these labels necessarily very well, so you can add something like a text shadow in order to kind of make it stand out. You could set the size of these circles based on other bits of data. You could change the color of these based on data that comes in through your topojson, but we'll save that for later. But for now, this is pretty good. We've made a map, we've put some dots on it, and that's really all anyone can expect out of us.